Hi everyone, in this video we will use implicit differentiation to find the first derivative of a given formula and to find the equation of the tangent line. Also you have to find the horizontal tangent line. For part A you have to use implicit differentiation to find the first derivative. So since the function in implicit form, you have to use implicit differentiation. So we have 3x squared plus 3y squared, but you have to multiply it by prime because y to the power 3 is a function in terms of y, equals to the derivative of the right hand side, and the right hand side is a multiplication of two functions. So name 3x u, name y v, and apply the product rule. So you'll get u prime, which is 3 multiplied by v, y plus u, which is 3x multiplied by v prime, and v is a function in terms of y, so the derivative of y is equals to 1, but you have to multiply it by y prime since it is a function in terms of y only. Then you have to group the terms that have y prime and put them on the left hand side. So you have to move 3x y prime to the left hand side and move 3x squared to the right hand side, and you will get 3y squared y prime minus 3xy prime equals to 3y minus 3x squared. Then take y prime as greatest common factor from the left hand side, 3y prime then you will get y squared minus x. Also you can take 3 as greatest common factor from the right hand side, and you will get 3 multiplied by y minus x squared. After that you have to cancel 3 with 3 and divide both sides by y squared minus x. So you will get y prime equals y minus x squared divided by y squared minus x. So this is the first derivative. In part B you have to find the equation of the tangent line, so you have to do 3 steps. The first step, you have to get a point, find a point x0 y0, and this point is given in the question. It's 3 over 2 and 3 over 2, so we can write it as 1.5 1.5. This is x0 and this is y of 0. So this is our point. So you have to go to the next one, or next step. You have to find the slope at x0. So the slope means the first derivative at the given point, 1.5 1.5, because y prime in terms of x and y, not x only. So you have to replace x by 1.5 and y by 1.5, and you'll get 1.5 minus 1.5 squared divided by 1.5 squared minus 1.5, and this gives us negative 1. So this is the slope of our formula at the given point. Now you have to tower to step 3. This is step 3, and you have to find the equation of the tangent line, which is y minus y0 equals m multiplied by x minus x0. Everything is given, so we have y minus y0, which is 1.5, equal our slope negative 1 multiplied by x minus 1.5. So y minus 1.5 equals to negative x plus 1.5. By add 1.5 to both sides, you will get the final answer of the equation of the tangent line, and get y equals negative x plus 3. So this is the equation of the tangent line. In part C you have to find the points in the first quadrant in which the tangent line horizontal. And you have to know that if you want to find the points in which the tangent line horizontal, that means the derivative equal to 0. So from the previous part, in part A, we found dy by dx. So you have to put it equal to 0 to find this part. So if we have a rational function equal to 0, so the numerator equal to 0, and you'll get y minus x squared equal to 0. By adding x squared to both sides, you will get y equals to x squared. Now you will substitute y by x squared in our formula here. So you will get x cubed plus y cubed, which is x squared cubed, equals 3xy, and y equals to x squared. So we have x to the 3 plus x to the 6 equals 3x to the 3. And now on the left hand side we have x to the power 3 plus x to the power 6. So you have to subtract 3x cubed from both sides. So you will get x to the 3 minus 3x to the 3 plus x to the 6 equals to 0. Now by group similar terms, we have this one and this one, so you will get x to the 6, and 1x cubed minus 3x cubed is minus 2x to the 3 equal to 0. Now you have to take the greatest common factor in the left hand side, and you can take x to the 3. You will get x to the 3 minus 2 equal to 0. Now we have multiplied two functions equal to 0, so the first function equal to 0 and the second one equal to 0. So we have x to the 3 equal to 0, or x to the 3 minus 2 equal to 0. For the first equation, you have to take cube root for both sides, and you will get x equal to 0. Now since y equals x squared, so when x equal to 0, y equal 0 squared, which is equal to 0. So we have the point 0, 0. And for the second equation, you have to add 2 to both sides. You will get x to the 3 equals 2. Then you have to take cube root for both sides, and you will get x equals cube root of 2. And since y equals x squared, so y equals cube root of 2 squared, which is equals to cube root of 4. So we have the point cube root of 2 and cube root of 4, and this is approximately equal 1.26 and 1.59. Now this is the point in which the tangent line is horizontal, but here in our question you have to take point in the first quadrant. So this point is neglected 0, 0, because it is not in the first quadrant. So the only point in the first quadrant that have horizontal tangent line is this point. And that's it. Thank you.